so I think we're moving forward. Yeah, so if you come to class on Monday and you tell me your computer doesn't work, well, that's not going to work out so well because I already asked you to please test your computer before you come, right? Right?
Correct.
Yes, sorry.
Yes.
Okay.
I keep forgetting that I'm on mute.
I understand. I don't really care if you're on mute or not. If there's background noise or you're like restless, then we can hear every time you move your glass or your dog barks, anything like that. If you're in a
We're
pretty
just
quiet
paranoid
place,
because of Corona.
what?
We're just paranoid because of Corona.
Oh, you think we're going to get it through the computer? That would be a bad virus, right?
Very.
Yes.
In the computer. Run away.
Oh my gosh. Oh, look, we have 24 people. This is nice.
Oh, wow.
Ahmed from Egypt. Talking from Egypt.
How are you? Hey,
Good.
Professor.
How are you?
I'm good.
Good. I asked about you the other day to find out if we were going to be okay, about what we were going to do about you not being able to get back, but now there's no 32 minutes, so I think can't.
Yeah, everything's been online now, so yeah.
Yeah, everything's online, so you're safe. Everything's good.
Yeah, thank you so much for that.
Of course. No, I was like, I don't know what to do with I have you and I have somebody else who's in Pakistan.
Oh, okay, yeah.
And I'm like, this is hard. What am I going to do if we start classes in 2 weeks? But it's okay. We're not going to, so no worries. No worries. I'm so glad so many people could make it this morning. This is fantastic. Makes me very happy to see you all here.
So, because all the semesters going online, there's basically no need to go to class, like to FAU for any test.
You should not go to FAU. Actually, I think they're locking down the campus.
Okay.
Oh my goodness.
Is there any pre-worksheets we have to submit?
There's a pre-worksheet that I gave out last class, and you should submit it today. Yes.
Okay. Yeah.
When are we allowed to go back to campus to get our stuff?
I don't know the answer to that.
Okay.
I really don't. I don't know anything about if you live on campus, what happens.
That's so much stuff.
Yeah, because the same thing happened to my friend at USF. He has all his stuff still in his dorm.
This is horrible. This is horrible. Are they going to embarrass us a half a semester? They better.
I will see what I can. I'm trying to think who I can ask that about that. I'm going to see if I can find out about how to get your stuff. Hold on.
Why not just message President Kelly? He doesn't seem busy.
Right? Do you have a number for housing? Does anybody have any? I mean, what I was.
I might have the number.
Huh?
I might have the number.
Yeah, I would email. I don't think they're probably going to answer because, like, literally now staff has been told to go home. I think as of today, I don't know if it's after today or today is the last day that the staff is on campus, but I know staff has been told to go home. So if you Don't.
Hello?
Yeah, hi. I was doing the same thing. I think she's on mute.
Yeah,
Yeah, she's on mute. All right.
So how's everybody enjoying the quarantine?
Hey, Chad, you're my dad.
Oh, God damn it, Johan, no.
It's been cool. I've just been muting myself and eating popsicles while in office hours a bunch.
No, that sounds like fun.
Yeah.
Nice.
Yeah.
I've been eating cereal. I'm working.
Drinking chocolate milk and eating banana bread.
Yo, bro, fuck, you are my dude. I'm drinking chocolate milk right now, too.
I'm eating Cocoa Krispies, if that counts.
No, it doesn't.
It does not count. No one likes
It's not chocolate. It doesn't count.
Okay, guys, I'm back.
Hello.
Hello.
Okay, so here's what I found out. Nobody knows. They're making their decisions right now. Just, stay tuned. Probably what they're going to do is have, make move-out blocks for everybody, I think it was Kale who asked me, Kale, you can go Tuesday between 10 and 12 or something like that. And then they'll have just a certain amount of people on campus at a time. So there's not, a big craziness. So I think that's what's going to happen. You just have to pay attention to your emails. Literally, your email now is your best friend. That's the only way I have to communication with you as well. So just pay attention, and as soon as they say something, go get your stuff. That's the best I've got right now. So, but that was the answer.
I'm so confused. So, even after these 2 weeks are done, do we still go back to school, or no?
Say it one more time.
After the 2 weeks quarantine is up, do we still go
There's
back?
not a 2-week quarantine anymore. You're not paying attention to your email.
Now
it's pretty much it's to the end of the semester.
Oh shit. Oops, sorry.
Going to the summer semester as well.
What did you say, Shoaib?
To the summer semester as well, because when I went to go at classes to plan ahead, all the classes that I'm going to take are now online.
Really? Okay,
yes.
There we have it.
I don't want to do that.
Me either.
I don't want to do that.
I don't want to take calculus either.
Do you have to go to school this summer?
Well,
I want to finish.
technically, I am behind, but the thing is that I do have to it doesn't really matter when I do my summer catch up though.
Okay, so here's the thing. Everybody just relax. This is something that's, listen, I'm way older than you. This has never happened in the United States before. So nobody knows what to do. Okay? Everybody's in the same place. I don't know what to do. All we can do is whatever it is that the next thing is that we can do. So we're here and we're going to learn math, and that's what we're going to do today. Understand? like, don't panic so much. Do you understand?
Yes.
Okay, so, like, just take it day by day, and it's going to be okay. We're all here. We're all alive. We're all safe. We're just not having fun being home by our, being home. But, we're all in the same position, so we all understand each other. Right?
Yes, ma'am.
Yes.
Okay. So I'm here. If you need anything, again, you can call me, you can text me, you can email me. If you want to just talk to me, just call me. I will answer my phone. I'm answering my phone. I'm really not doing anything either. I'm not out eating. I'm not having dinner out. Maybe I'll be eating something when you call, but in general, we're all in the same place. So, okay?
Okay.
Okay. Everybody's good? Ready to learn some math?
Let's do it.
Let's do it. Okay, so first thing I have to do is I have to share, hold on, share my, can everybody see my PowerPoint?
Yes.
Yeah.
All right,
Yes.
good. Let's see if I can make it into a slideshow.
Wow.
Wait, it's weird. It's like showing the non-slideshow bigger.
Okay, I got, so let me see.
Oh, that sucks.
So which way is better? So is it better without the slideshow? Like, can you see me changing things?
Yes.
Yes.
Okay, so I'm going to put it in slideshow mode. You tell me if it's... I guess I could make this thing on the side look smaller. Hold on. I can do this. Is that better?
Yes.
Yes, that's good.
Okay, perfect. Then let's do this. So these are really important properties of logs. And remember, we said that if we have... Let me see how to write on the screen. Oh, here I go. So remember we said if we have the log base something of x equals y, then that means that e to the y equals x. Remember that?
Mm-hmm.
Hopefully that's a yes. So notice here, the log base b of b is always 1 because the log base b of b has to equal 1 because b to the 1 equals b, right? Does that make sense?
Yes.
So that takes care of this. And it should take care of the second one as well. Right?
Yep.
Yeah.
Okay, good. Now let me see if I can let's see if I can go to no. Perfect. Let's see how to do that. Oh, there we go. Great. Perfect. Okay, we'll get it. Don't worry. Okay, so now, why are these two properties true? These two properties are true. Basically, they come from the composition of the function with its inverse. Okay? We have these two things that we already learned are true. When I compose the function with its inverse, they both equal x, right?
Yep.
So now, what if I say that the f of x equals log b of x, and f inverse of x?
Can you mute yourself?
Yeah, can you mute your somebody's loud.
Yes, whoever's loud, mute yourself. Okay, I don't think that's me.
No.
Equals b to the x. So these would be inverses of each other, right? So now if I do the composition here, I would have f composed with f inverse of x, and that's equal f of f inverse, but f inverse of x is equal b to the x. So now I plug b to the x into log base b of x, and I get log base b of b to the x. But I already know that equals x because this is true. Okay, so does that make sense? So that takes care of, let's see, I'm doing log base b. That takes care of the exponential form. That's why that is true. So notice when we see something like this, you can look at it like log base b of b cancel. Okay? And the same thing is true over here if I have f inverse of f of x, that equals f inverse, and f of x is equal to the log base b of x. But f inverse is b to the x, so this would be equal to b to the log base b of x, which, since they're inverses, we say it equals x. So notice now that cancels. So when you see these two kind of functions together, this part cancels. It's not really cancel, it's really like it cancels because they're inverse functions, and this part cancels. Do y'all see that? How that works?
Yes. Could you write the log b, a log to the base b, b to the x power? Could you write that in exponential form?
Log, say again, log base b.
B to the x power. Could you write that in exponential form? Equal x.
Well, this just equals x. I'm not sure what you mean.
Like, is there a way to write that in exponential form?
Well, if we said this equals some function y, then b to the y, right?
Right.
Equals b to the x.
Oh, I see.
It means x has to equal y. So that just makes this y equal x.
Okay.
Did that answer your question?
Yes, ma'am. That did.
Okay, perfect. Perfect. Hold on. I'm just going to keep checking my emails just to make sure you guys, like, not you, but somebody is like, okay. Nothing. Okay, so these are really important properties. Okay, you'll use these often, like really important. You'll use these in this class, but you'll also use these a lot in calculus. Okay, so now we're going to start solving a basic logarithmic equation, right? So here, we're not going to use the calculator, that's all. We're going to do everything like as if we were going to put it into a calculator, but we're not going to use a calculator. So does everybody remember what ln of x is the same as?
Yes, it's log base.
Log base b, right, of x. And if I have a log that's just log x, this is called the natural log. And this right here is called the common log. Okay? So for A, what I have is, I have log base b of x equals 2, which means that x equals what? So let me see. I'm trying to see if I can. I don't have the chat box up in front of me. So let me see if I can get. Oh, I guess. Okay. So anyway, if you want to talk, just talk. But this is equal to e squared because e squared equals x, right?
Mm-hmm.
So if you're typing, I can't somehow see it at the moment. All I can see is my PowerPoint. So just unmute yourself and then mute yourself back. I can't even see if you're raising your hand, so I'm really sorry. So for B, I would have minus 0.52 equals log of x. So can I have the log equal a negative number?
No.
No.
I
No.
can. So I want to make sure that you understand x can't be negative, but it can equal a negative number because if I look at a log function, remember, it looks like this, right?
Right.
So all the things,
It can be negative. Is that what you're
yeah, so notice here, all this down here is a negative value, isn't it? So don't get confused. X cannot be negative, but the log of x can be negative.
So the domain can't be negative. That's what you're trying to say.
The domain can't be negative, but the range can.
I see.
Okay, so does everybody see the difference?
Yeah.
Okay, good. Be careful of that, because I know I've seen people say it can't be negative, but it can. And it's always going to be negative. Remember, this point right here is 1, 0. So it's always going to be negative between 0 and 1. When x is between 0 and 1, the log is negative. So this is really just saying 10 to the minus 0.52 is equal to x, right? And then you just take out a calculator. Does that make sense to everybody?
Yes.
Yep.
Okay, any questions?
What would that, like if we solve in that for the calculator, what would that be on the graph?
So for B?
For X. Yeah, for B.
For B would be, I'm not exactly sure. Here, let me just see. So I don't know the exact value, but it's going to be somewhere over here, right? Here.
No.
Right? It's got to be between 0 and 1. You just have to remember it's definitely going to be between 0 and 1.
All right, thank you.
And if I don't answer your question, just tell me. I'll be sure to answer it. I want to make sure I do. All right. So if we wanted to solve for x, if we want to solve a for x, how would I solve that? Any takers? Yeah, it's pretty hard, right? Like
I can do it.
You can do it?
I think so, yeah. You just put ln on both sides, right?
Yeah, so if you take the natural log of both sides, then this is really the same as log base e of e to the x. But if you remember the rule, this is just equal to x. And now look, I solved it. So now I know x, if I have a calculator, I can tell you the exact value. Does that make sense to everybody?
Mm-hmm. Yes, you basically just, since it was just you just to use the ln and then on both sides, and since ln is log e base, it just cancels out.
Yes,
Right?
exactly. So I can't really solve an exponential, but if I take the log of both sides, which I can do, as long as I do the same thing to both sides, I can do anything, right? So I take the log of both sides, and then once I do that, because of my properties, basically the inverse composed with the function cancel, and I just end up with x, which is what you expect, the square root of x squared is x, right? The function with its inverse cancel out, and that's what's happening here. So anytime I have an exponential and I have my variable in the exponent, I can't solve for it unless I take the log of both sides, okay? So for b, I would take the log of both sides, and because, I'm sorry, I'll just cross it out.
So we don't have to find the exact value.
You do have to find it, or you will, if you put it in a calculator, you'll find the exact.
Okay.
Yeah, I wouldn't know the exact value without a calculator.
Right.
Yes, but remember, when there's no base, it's base 10. So that would cancel that, and I would have x equals the log of 8.22. And that's the log that you have in your calculator. The log on your calculator is log base 10. Okay? Any questions? Very good. Now we're going to solve equations. How would I solve A?
29 on both sides.
Yeah, I would just add 29 to both sides. So this is 80. And then I would
Log each side.
I would take the log of each side. Perfect. And that would cancel, and I would get x equals log of 80. Right?
Yeah.
How about B? How would I do B?
Add 5 each
I
side.
would add 5. Good. So I have 3e to the x plus 1 equals 12.
Then you would divide by 3.
Yes. Make sure you divide by 3 first. Because if I'm going to take the log of both sides, the log has to be next to like the log base 10 of 10. The log base e of e. I can't have it be 3 e to the x plus 1. I can't use the same property. Okay? So you have to get rid of that. The log and the base need to be, the log and the argument need to be next to each other. Okay? Does that make sense what I'm saying?
Yes.
Okay, sorry. And I didn't take the log of both sides. Now I did. So now this cancels, and I get x plus 1 equals ln of 4. And then I just subtract 1 from both sides, and there's what x equals. And I can find an exact value. I just need a calculator. Without a calculator, you cannot.
I have a question.
Yes, sir.
With that -1 there, would there be a way to find the exponential version of that? Like,
So you're saying if I started out with x equals ln of 4 minus 1?
yes, is there a way to turn that?
Remember, this is 4 minus 1. Yeah, I would just say x plus 1 equals ln of 4, right?
Oh, okay.
And then I would, since the way to cancel out an ln is, so the way to cancel out an exponent, it was with a log. So what do you think the way to cancel out a log is? I'll say it again.
Say that again?
Yeah, I'll say it again. So if the way to cancel out an exponent, remember up here, we cancel out an exponent by using a log, right?
Oh, use an exponent.
So to cancel out a log, I have to use an exponent, right?
Right.
They go backward, and forward. So here I would just say e to the x plus 1 equals e to the ln of 4. And that's the other one that works. That cancels, and I get e to the x plus 1 equals 4.
Ah, okay. All right. Thank you.
Okay?
I have a question as well.
Yes.
For the minus 1, do you subtract the one after you do the ln 4 in the calculator, or you subtract the 1 from the 4?
No, it's ln of 4 minus 1. Yes.
Okay, thank you.
Okay. Good question. Any other questions before we go on? So how's this working out? Okay, so far pretty much the same as when we're in class, right? Except we can't see each other.
Yes.
It's okay. You're okay with this?
Yes.
Okay, good.
I can't see your beautiful face.
Oh, you're so sweet. I know that was Joe.
Yeah.
All right. So now we have these three other rules. So we're kind of building rules. We have the 4 rules from before, the 4 properties from before, and we have these 3. And I think we might have 1 or 2 more, but it's not a lot. So don't worry. There's only a few things, and they get pretty. We use them a lot, so they're not hard to remember. So here we have the product rule, which says that if I have 2 values multiplied together, say for example, if I have the log base 2 of 4x, that's going to be equal to the log base 2 of 4 plus the log base 2 of x, right? Because I can separate them into something plus something. And if you're wondering, I mean, I'm not going to go through the proof of it just because it takes more time than necessary. But if I have an x, remember these are inverses. So remember this becomes plus. So notice I have something times something equals something plus something, right? So that's basically, if you want kind of a way to remember it, that might be helpful. The same thing is true here. When I have a base to a power over a base to a power, remember I subtract. So notice here I subtract, which means if I have log of, let's say, 3 over x, that's equal to log of 3 minus log of x. Okay? So far, so good. Now, let me see where my erase. I have erased this before.
That's good.
Yeah, hold on. You have a question?
No, I was just saying it's good.
Just what?
Just saying it was good.
Okay, good. Let me see. I erased before. No, I erased. Oh, I think I just corrected. Everybody has everything copied that you want?
Yes.
Okay, so now, how does this power property work? Basically, this says if I have a log, whatever base it is, base b of 3 to the x, that's equal x times log base b of 3. So the power rule basically says this moves to the front. The exponent moves to the front, okay? And I'll show you why that works. It's pretty easy, that's why I can show you that. So let's say I have log of x to some power, right? I can say this is the same as the log of x times x times x, however many times I have this m times, right? But we can also use our product rule that says that if I have the log, if I have something times something times something, this is really the same as log of x plus log of x plus log of x plus log of x, and I have m of these, right? So if I have something m times, it's the same as saying m log x. So notice all I'm doing is bringing the exponent to the front because we're really doing just a product rule many, many times. Does that make sense to everybody?
Yeah, that makes sense.
Yeah.
It's weird, but it makes sense.
It's weird, but it makes sense. I know it is. It's weird, but it works really nicely. And we use it a lot because it has such nice properties, honestly. So this is also very important. I think if I write with the other thing instead. So notice here, what it's saying is, it is not, what we're doing is going, we have a product rule, and we have a quotient rule, and we have a power rule, okay? So right here, the one I just underlined, we don't have a sum rule. So you see that that's the sum of two values. You can't just separate the sum. There's nothing you can do with the sum. It just stays at the sum, okay? Do y'all get what I'm saying about that?
Yes.
Okay, good. Now, the second one right here, that says the log of m over n, but it's not equal to the log of n over the log of n. It's equal to the log of m minus the log of n. So don't get confused. That's how things get confusing. You might even want to write down the rules before you start so that you can see what is actually happening. So for example, A, I have the log of 2 to the log base 2 of 7 plus log base 2 of 5. So if I look at that, I can say, well, that's the same. Here, let me write the rules. So if I have the log of m times n, that equals log m plus log. So well. I'm going to take off the annotation. That thing doesn't work as well. Sorry about that. So yeah, it works better without that. Log of mn equals log of m plus log of n. Here, I'll write it over here. Log of m over n equals log m minus log n. And then if I have log of m to the n power, that equals n log m. Okay? So those are basically the three rules. One's the product rule, the quotient rule, and the power rule. So just for A, I can say this is equal. So I have a log of something. I have two logs with a plus between them. So I'm going to use this rule here, which says if I add them, then I multiply them. So this is equal to the log base 2 of 35. Does that make sense to everybody?
Yes.
Mm-hmm.
Okay. And if it doesn't, just chime in and say no. Okay. And I appreciate those of you who are saying yes because it makes me know that you're hearing me. So thank you.
Doesn't have to be the same base always, right?
It does have to be the same base. Yes, you can't add them together if it's not the same base. Okay, so now for B, well, can I add these two together? What do you think this would be? Does anybody want to give it B a shot?
You said B?
B, yeah.
I can.
No. Whoever, I don't care. I'm just trying to see if you understand or if there's something more I need to explain. I don't just do it without you. So go ahead.
Would it be like IN X
It's
plus
not IN. So first it's not
LN,
IN.
sorry.
It's
I keep on,
yeah, that's okay. That's okay. I just want to correct you to like.
Would it just be LN? Yeah. It would be ln x plus 6 squared, like the x plus 6 in parentheses squared.
No. Okay, good. So no, that's not correct, but that's okay. Now I'm kind of understanding what you're seeing. So, does you else want to take a shot?
Yeah, I can take a shot.
Yeah, go for it.
All right. So first thing, you would put ln x to the square root of 2. Would be the first thing you would.
Not
do.
the square root of 2.
Oh, you wouldn't put it to the power of 2? My
To
bad.
the power of 2, so I would
Okay.
square it, not the
Yeah.
square root.
I
So
apologize.
yeah, the first thing I would do, because you can only add an ln with an ln, you can't add a 2ln. Do you understand that?
Yes.
Okay, good.
And
So then I have this. Exactly.
all
And
right.
then what's next?
And then after that, you would turn it into ln, and then open parentheses, x squared multiplied by parentheses x plus 6, close parentheses, close.
Perfect. That's exactly right. So see, it says write each as a single term, and now we have a single term. Did everybody get that?
Yeah.
Could we distribute that or no?
Yeah, sure, no problem. You can distribute or not distribute, I don't care.
Okay.
Okay? So how would we do C?
Wouldn't you just do, wait, can I just answer it or just like anyone?
Well, what I'd like, I kind of recognize your voices, but I don't recognize them all, and I can't see who's talking because I literally can only see my PowerPoint. So if you could just say your name, and if you're answering, don't answer all the time. Give someone else a chance. That's all.
I'm Yoan.
Hi, Yoan.
So, yeah, do I answer or not answer? Because I don't know.
Have you answered like 20 times already today?
I don't know.
You can have one more.
All right. Wouldn't
And
just,
I'm going to stop you for a while, okay? I know Ian's been answering a lot. I recognize you.
wouldn't it be like ln x plus 2 over x because you're subtracting?
Yes.
All right.
Exactly. Perfect. So does everybody understand this?
Yeah.
Is there any questions? Just turn your mic on if you have a question.
Yeah, this is Sai.
Hi, Sai.
Yeah, I have a question. In B, I'm confused as to why you multiplied it instead of adding it. Because I thought it would be x squared plus x plus 6.
Because look at the rule here over on the top right. Basically, it says, let's look at it opposite. So we have the log of mn equals log of m plus log of n, right? So that means that the log of m plus the log of n equals the log of m times n, right?
Right.
Do you see the difference between what you're saying?
Yeah, okay, yeah, I saw it now. Okay.
Okay, perfect. Thanks for asking me, Sai. Any other questions? All right, onward. Okay, so power property, to rewrite its term as a product. So A, ln of 5 to the x. Somebody new.
The ln ln5 equals x.
No, not exactly. So the power rule, wait. So the power rule says that the log, whatever the base is, of m to the n power is equal to n times the log base b of m.
Oh,
Okay.
so that's ln5.
X ln 5, exactly. Good?
Yes.
Okay, I'm going to do C next because B is a little trickier. So does anybody want to do C?
Isn't it 1/2 log x?
That's it, perfect. 1/2 log x. Because this equals log x to the 1/2 power, right? Okay, so any takers for B?
Me, Stefano.
Who is it?
Stefano.
Hey, Stefano.
Hey. So I would say x plus 2 as the whole exponent goes in front.
Yes.
And then log 32. Right?
So did you want me to write it like this?
With parentheses with x plus 2.
Yeah, so the parentheses have to be around the x plus 2. Now, I said it was a little tricky because you can actually simplify this more. Do you see it?
Yeah, I think you can make the 32 base 2 to the 5,
Yeah, good, beautiful.
and then distribute it to the x plus 2.
Perfect. So this would be the same as 2 to the 5th, which means that this is 5 times x plus 2 log 2. Does everybody see that?
That's insane. Okay, that's
Good though, right?
oh yeah.
Okay. Any questions?
I have a question.
Yeah, sure.
For D, do you have to put, because is it a single product? I mean, is it like 32, 5, 2 to the, fifth power? Did you have to do that? I mean, it is,
Well,
do it.
I mean, it depends on the question, but I do want you to see all. There's no right answer here because we're just doing problems, right? I'm just trying to show you different things. So I don't know if it says simplify as much as possible, then 32 would not be correct because you can simplify that more. But it depends on what it says in the question.
All right.
You know what I'm saying? Don't get too hung up on every little piece because it'll be okay. Whatever, we'll figure it out as we go. So now we have all. Do you want me to write the rules back up on the screen? I guess probably so. So we have the log of mn. And we have log of m over n equals minus log m. And we have log m to the n power equals n. Okay, so somebody new. Do I have any takers for A? A is probably the easiest.
I'll try it.
Okay.
So is it 2 log x plus v?
So 2, no. Be very careful. So you have to do this in pieces. Thank you though. So you have to do this in pieces. So are they both squared?
No, it's just x.
So what rule would you use first? So this is the product rule, quotient rule, and power rule. So which rule do you think you'd want to use first?
I would do the power first.
Yeah, so they're both not to a power, so that wouldn't work out so well. You see what I'm saying?
Yeah, I do.
So the first thing you'd want to do is use the product rule, because you want to separate those into 2 pieces, because if it was x z squared, yes, you could do that.
Oh, okay, I see.
You see why you can't do it otherwise?
Yeah.
Okay, good. So this becomes what? If
it would be log x squared and then log z.
Plus log z.
Yeah.
Yes. Perfect. And now, I'm just going to go straight across and then I'll do the other ones down. So then this is equal to what?
It'd be 2 log x plus log z.
Perfect. Do you see that it would have been different if I had put the 2 in the front?
Yeah.
First? Okay, good. Very good. Any questions on this? All right. Any volunteers for B?
I can take a shot at it.
Yeah, let's do it.
Would you want to separate it using the quotient first? The quotient problem?
How would you do it? May be. It depends on how you do it. You have to be very careful because that's square roots over the entire thing, right?
Yes.
So if you don't do it correctly, you're going to make a mistake. So that's why I want you guys to do it, because I want to see what mistakes you might make and correct them.
The way I was thinking is that you do the I and ln, sorry,
It's okay.
square root x minus ln square root x plus 5, or no?
You can do that because they both have the same. What is the square root really the same as?
It's 1/2.
To the power of 1/2. So remember I said because they're all, because it's all to the same power.
Uh-huh.
You can do what you said, or probably the easier way,
Would just
and I'm not sure if that's easier, is to just make this x over x plus 5, the whole thing to the 1/2 power.
Okay.
Now you see how these are different.
Yes.
Because, yeah, the whole thing is the 1/2 power, where the other one was just the x was squared and the z wasn't.
Yeah.
Okay, and then you would do?
You would do the power property.
Yes.
And then,
Yes.
yeah.
Perfect.
And then you would do the quotient where you would end up with ln, it would be 1/2 ln minus, 1/2 ln x minus ln x minus 5.
And there's only one thing missing from what I wrote.
Is there another 1/2 or no?
Yeah, so this is actually in parentheses.
Okay.
Or if you want to distribute it, you can, but it goes, that 1/2 goes to both pieces because the whole thing is to the 1/2 power.
Okay.
Make sense?
Yes.
Perfect. All right, any volunteers to speak?
I can try it.
Okay, who's talking? Okay. All right, Ahmed, let's do it.
So, we will make the root be 1/2.
Sure. So ln of e x to the plus 1 to the 1/2 over 2x plus 5 cubed. All right.
So then that will be equal ln e plus ln x squared plus 1 to the power of the half.
Do it in pieces. Don't do all of it at once because it's way too easy to make mistakes. So what would be the next rule you would use?
It will be like ln e, which
So what I would do next is I would separate the fraction into two pieces.
Okay, so it will be ln e x squared plus 1 power half minus ln 2x plus 5 to the power of 3.
Perfect. Perfect. And then?
Then we have to separate the first one to it should be ln e plus x to open the parentheses x squared plus 1 to the power of half.
You forgot to say ln.
Yeah, ln.
You just have to make sure you put the ln in there. Oh, I assume you wanted it, but I just want to make sure in case you didn't.
Yeah, I forgot to say it. Yeah.
It's okay. That's okay. I understand. And
then we would put the half before the ln and the
I'm going to just copy this here. Okay. Hold on. Okay.
Then it will be like ln e. It will be equal ln e plus half ln x squared plus 1 minus 3 ln 2x plus 5.
Good. Hold on.
Is the ln e the number?
Oh, that's good. Well, so what is ln e?
It's like 0.
So remember, log base b of b is always equal to 1, right?
Yeah, so that's equal to 1.
We have log base e of e, it has to equal 1. So this is really 1 plus.
1, yeah.
Okay?
Yeah.
Does that make sense to everybody? I guess that's it. Any questions?
It's just complicated. Like, it's easy to get lost in it.
Can't
You
you
just have to be really organized. So let me just say this: when you we are now about to head into calculus, right? So calculus problems are even longer than this, and calculus 2 problems are even longer than calc 1 problems. So you have to learn how to stay organized. That's why I'm really I try to get on you about your work. Make it really slow so that you can read it. It's not a complicated process, but if you don't stay organized, yes, you'll get lost. Absolutely. Any other questions?
Yeah, can't you, can't you simplify it further?
How? Is that you, Sai?
Sorry?
Is that you asking me?
Sai.
Yeah, was that you who asked me if you can simplify it further?
Yeah.
That's what I thought. So how could I simplify it further?
Yeah, I was thinking you could take the 1/2 ln x squared plus 1. You could multiply it. You can make it 1/2 ln x squared because it's x squared plus 1. Actually, wait. Oh wait, no, never mind. I went off on a different.
Did you see a mistake?
Yeah, I was taking x squared plus 1 as x squared plus ln 1. Okay, yeah.
Yeah, no.
Okay, yeah. Sorry, my bad.
No, it's okay. I appreciate you ask. Honestly, Sai, I'd rather you ask than not ask. So you're doing fine. I'm happy. Okay?
Yeah, thank you.
Does everybody see it? All right. Go on. So now we have change of base formula. And change of base formula, actually now is when I can show you why the negative base of a log flips over the x-axis instead of the y-axis by using change of base. So basically, change of base says that the easiest way for me to remember it is that the base always goes in the bottom. So the argument goes on top, and you have to match the bases, okay, whatever the base is. So let's say I have log base negative b of x, right? Remember we were going to say, how is it that it flips over the x-axis? It didn't actually make sense, right? So let's use our change of base. We can say this is equal to the log, it doesn't really matter what the base is, of x over the log of negative b, right? So
You can't do that.
no, you can't. Well, you kind of do. Yeah. So wait a second. What is it I'm trying to say? Oh, I know what I'm trying to say. Sorry, it wasn't when it was negative. It was when it was a fraction. Remember, it was when it was a fraction. It flipped over the x-axis. So what I can do is I can say this is equal to the log of 2 to the minus 1 power of x. Now using change of base, I can say this is log of x over the log of 2 to the negative 1 power, right? But I can now use my power rule, and I can say this is the log of x over negative 1 times the log of 2. Using my power rule, that negative comes out front, which makes this negative log of x over log of 2, right?
Right.
And I can now put this, if I go back the other way, so I'm starting, well, let's see, I'm using base 10. So I'm starting this side now, and I'm going to go to this side. I can say this equals the negative log base 2 of x. And now look, I turned my base that was a fraction it actually is the same thing as a negative log. And using transformation of functions, that would just flip over the x-axis anyway, right? So that's why the log flips over the x-axis when the base is between 0 and 1.
Oh, crazy. I'm not even lying. That's dope.
Right? Nice, right? Logs are kind of fun, and they're really helpful because you can manipulate a lot of things using logs that you can't do otherwise. Now, please, here's what I see every time I teach logs. Don't do this. People say, well, I have x squared. Like, I can just bring the 2 out in front. No. X squared is not equal to 2x, and I know you know that. Don't get crazy. It has to have a log in there to use log rules, okay? So it just becomes kind of habit at this point when we do logs, and I've seen that too many times, so I'm just trying to point out that's not true. X squared is not equal to x. Log of x squared equals 2 log x, okay? All right, so let's just do one. Basically, I'm just going to do this is really quick. It's just a matter of understanding the formula. And all this means is if I have log base 3 of 29, this is equal to log of 29 over log of 3. And it's also equal to ln of 29 over ln of 3. And it's also equal to the log base 1,237 of 29 over log base 1,237 of 3. So what am I doing? I'm just saying the bases have to match. As long as the bases match, these are all equal. The argument goes on the top and the base goes in the bottom. Y'all see that?
Yes.
These are the ones we're going to use most often because on your calculator, this would not appear. But I can use the log to find an exact value, or I can use ln. Those are both on my calculator. Log base 3, I know some people have calculators that have bases, but it's uncommon. Okay? Everybody understand? No questions? All right.
Yeah.
Okay, perfect. So now we're going to start learning how to solve logarithmic equations. So I can't really solve this because I don't know the answer. But what I can do, I want to solve for x. So what I can do, I'll do the first one. Does anybody know what to do here? Or do you want me to do the first one?
I know what to do.
Yeah, I just need to refresh.
Who is it? Who knows what to do?
I think it's me.
Is that you, Julian?
No, that's me, Johan.
Johan, I don't want you to, well, does anybody else besides Johan know?
I probably know. I can do it.
Who's that, Ian?
Yeah, that's me.
Okay, so Ian and Johan. Anybody besides Ian and Johan? Okay, Johan, go ahead. Tell me what you would do.
Okay, first I would combine log x with log x plus 3, and next I would factor in x.
So I would get what? At log of?
X and parentheses x plus 3.
Good. So I just combine them using the product rule, and that equals 1.
Yeah.
Right?
Then I believe I would try to cancel out the log for
what? Okay, how would you cancel it?
By I would believe, dang. This is where I guess I get kind of lost.
Okay, so look, we're going to use this rule.
I can say it. Yeah. I can.
Who was that?
It's Ahmad.
Who was it?
It's Ahmad.
Oh, hi, Ahmed. So
Yeah.
So here we're going to use this rule, right?
Yeah.
So how would I use it?
It is the same base.
Yeah, so what's the base on the log?
10.
10.
Yeah, so there's no base, so it's base 10, right?
Yeah.
Yeah, so 10 power 2, power 1.
So
I can, if I take them both to the base of 10, then this crosses out, doesn't it? Like
yeah.
this crosses out. And I end up with x times x plus 3
Equals 10.
equal 10 to the 1 or 10, exactly. Does everybody get that?
Yeah.
Yes.
Wait, I'm sorry. Why does it become 10 after you cross out log 10?
Because this rule up here says that if I have the base b to the log base b of anything, whatever this is, these cancel and I get whatever that thing is, right?
Okay, so the base
Is that you, Sai?
Yeah.
You're cutting out. Can you get closer to your microphone?
Yeah, so the base itself becomes the exponent?
No, it's not becoming the exponent. It's canceling.
So it's canceling it out, okay.
The base is canceling with the base of the entire exponential function.
Okay.
I mean, the other thing you can say is if I have log base 10 of x times x plus 3 equals 1, 10 to Can anybody hear me? Hello?
Yeah. Something
Oh,
cut out now. I
can
hear
hear
you.
you now.
Yeah, I can hear you again.
Okay, good.
Yeah.
So we're all back? Sorry about that. Hold on. Let me go back and share.
Okay. Technical difficulties.
Yeah, what happened? It all just stopped?
Yeah, I mean, we could still see your screen, but we couldn't, like, hear you speak.
Okay. Yeah, I couldn't hear you guys either. So I want to share. Okay. All right. So, can you all hear me again?
Yeah, sir.
Okay, perfect. So how do I solve this? Hello?
Oh, right, 10 over.
It would be x squared plus 3x minus 10.
Yeah. So we have to move the 10 to the other side, make everything equal to 0. Then we're gonna factor this, right? X plus 5, x minus 2.
Greenberg?
So x equal, yes.
Super small question. But most of this class is not from my section. Should I also go to the other lecture that
you
you
don't
plan
have,
on going
not
today?
today.
Okay.
On Friday, I'm gonna, what we'll do is have 4 of you go to the morning one and 4 of you go to the afternoon one.
Okay.
So you can help, but you don't even have to stay, Jordan. You're good.
Okay. All
Have a
right.
good one.
All right.
Thank you.
No problem.
So we have x equals minus 5 or x equals 2, right?
Yes.
So is there any problem here?
No.
Yes, it is.
What's the problem?
Can't have a negative.
Right, x can't equal negative 5. It can only equal 2.
Sorry, Greenberg.
No, it's good. Now, here's one really important thing. Let's say, and I don't have it, but let's say I had log of negative x plus log of x plus 3, right? And let's just say, for example, those were my 2 answers. Let's make it minus x plus 3. Now, 2 wouldn't work, because 2 would make me, I would have a negative here, right?
Right.
So don't just assume because it's negative it doesn't work. So here, only if it was here, only negative 5 would work, right?
Right.
Because I can only take the log of a positive number. So don't just make the assumption that the negative value is always not true. Right?
Mm-hmm.
Okay.
Yeah.
Good. Let's see. So the uniqueness property, just like the uniqueness property of exponents, we have the uniqueness property of logs, which says if I have the same base of a log, then m has to equal n, right? That has to be true. So here, I can use that idea to say, so here I have log of x plus 2 equals, what can I do on the right-hand side?
Oh, you can just do log 7x?
Yeah, I can say that equals log of 7x, right? Sorry, and since there's a log of both sides, I can say x plus 2 equals 7x. And now I can solve. Does that make sense?
Yeah.
Mm-hmm.
Does anybody want me to do B?
Nah, I think we're good.
Good. All right. So if I want to solve A, somebody besides Joan and Ian and I think Layla's already done one, Stefano's done one. Who else hasn't done one that wants to take a shot? Actually, let's do B first. B is the easier one, I think. Nobody but Johan. Nobody? How about you, Sai? What?
I can do it.
No, Ahmed, you already done it. No, sorry, I forgot Ahmed.
I'll try it.
Okay, who's that?
That's Sai.
Sai. Okay, Sai. Let's do B.
Okay.
So what can I do here?
So first thing you could do is cancel out. Sorry. Into log x plus 12 over log x.
Get closer to your mic. When you're close to your mic, I can hear you fine.
Sorry. You could you could turn it into log x plus 12 over x.
Perfect. This is equal to log x plus 12 over x.
Right. And which equals to log x plus 9.
Perfect. And then?
The logs get canceled out.
Then the logs cancel, and I just get x plus 12 over x equals x plus 9, right?
Yeah.
How would I solve this, by the way?
Well, first thing I think you would do is basically algebra at this point, right?
It is all algebra, yes.
So you would just multiply x on both sides, which would cancel out the x on the left, and you would get x squared plus 9x.
Yep.
And then you would make it x times x plus 9.
No, I wouldn't do that.
Yep.
So how do I solve any quadratic equation?
Oh, make it minus x both sides.
Yeah, so I have to move everything onto the other side, right? And just make it 0 equals x squared plus 8x minus 12.
Yeah, and then and then I can factor it.
Then we factor it.
Yeah.
So we get.
Let's see. X minus 6. Sorry, x plus 6. X minus 6 minus.
I don't think this is factorable, by the way.
Should be, right?
Because I don't know what you can multiply. One of them's got to be positive, one's got to be negative, and that's too big of a positive number, right?
No, it's not factorable.
It's not factorable. So here we just need to use the quadratic formula, right? So we would get x is equal to -8 plus or minus the square root of 64 minus 4 times 1 times minus 12 to be plus 48 over 2. So this equals -4 plus or minus the square root of 112 over 2. So one thing I can say is it can't be -4 minus something, because that would be a negative value, right?
Right.
So it can't be that. So it's just got to be -4 plus whatever the square root of 112 over 2 is my solution. Okay? Good job, Sai. Now, one thing I just want to point out, one thing is when I multiply both sides by x and get rid of the denominator, I have to make sure x does not equal 0. Because if x ended up equaling 0, I wouldn't know that that's not a solution because I lost it. That's an asymptote, right? So whenever you're doing algebra and you multiply both sides by the denominator, if the denominator is a variable, please make sure that you remember that whatever that denominator is, we can't let it be 0. Okay?
Yeah.
Can you all hear me still?
Yeah, I hear you.
Okay, I just want to make sure, because last time I said that I didn't have any answers, so I want to make sure I'm still with me.
So,
okay.
I have a question.
Yes, sir.
So if it was equal to 0, it would make even the log undefined?
Everything would be undefined. Because here, at the original, right, I would say, well, and also I can't have the log of 0, so right there it wouldn't work. Like, it wouldn't work.
You could have a log.
Go ahead.
You can't have a log of 0? I thought it would be like.
No, remember there's an asymptote at 0.
Oh, yeah, you're all right.
Okay? So you just want to take everything into, I know there's a lot of things you have to take into consideration when you're doing these, but just make sure you do it. Okay?
All right.
Any other questions? Let me see. I have a ton more. I don't know if I want to do A. Let me see. Actually, I think I want to do this one. I just want to see what else I have here. I don't really want to do that. Oh, good. We actually are almost done. Okay. So, maybe we'll do this. We'll do A. So I'm going to erase what we have here so I can do A. Okay, so with A, time is it? So I'm going to hurry up a little bit because I know I'm going to take a little bit of time. So I'm just going to do this problem, okay? So first thing I'm going to do is I'm going to figure out how to combine these. So I'm going to use my power rule. And I'm going to say that equals 0.9. And the next thing I'm going to do is I'm going to use my quotient rule and say that this equals ln of x plus 7 over 5 squared, which is 25. And that equals 0.9. Now, because I don't have the log on both sides, I can't say x plus 7 over 25 equals 0.9, right? What I'm going to do is I'm going to make them both have a base of e. So this becomes e to the ln of x plus 7 over 25 equals e to the 0.9. And I'm going to cancel my e with my ln, and I get x plus 7 over 25 equals e to the 0.9, which means I have x plus 7 equals 25 e to the 0.9, and then I just say x equals 25 e to the 0.9 minus 6. And that would be my final answer. So did that make sense to everybody?
Yes. It's math.
Yeah.
Yeah, it's math for sure. Any other questions? Okay, so last. This is actually going to be our last slide. This one's a little tougher because notice we can't make the bases equal, right? And I can't really solve this unless I use logs. Okay, so you do have a problem like this in ALEKS, and this one's kind of complicated. It's not once you see it done, it is without seeing it done. So let me show you. So obviously the first thing we would do is take the log of both sides, right? Because we can't do anything when the exponent has a variable. Y'all agree?
Yes. Will we take the ln or the log?
It doesn't matter. Now with ALEKS, it'll actually tell you take the log base 10 or use ln. But here it doesn't matter. So you guys pick because it doesn't matter. So I'll pick ln. Less things for me to write. Okay? So I'm just going to take the natural log of both sides. And then I'm going to use my power rule. And I'm going to say x plus 1 times ln of 5 is equal to 2x times ln of 6. And remember, I've got to solve for x. So if I want to solve for x, this looks pretty hard still to solve, right?
Mm-hmm.
Anybody have any ideas of what I can do next?
Can you divide the ln 5?
You can, but if you have, let's say you have x plus 1 times 7 equals 2x times 4. Would 7 be the first thing would dividing by 7 be the first thing you would think of to do here?
No. Distribute.
You would distribute. So that's what I'm trying to have you see, is that you want to do the same thing you would do. So remember, ln of 5 and ln of 6 are just constant. If you type them into your calculator, you get the same number every time. It's a constant. It's not variable. Okay? So I'm going to distribute this. I'm going to say this is x ln of 5 plus ln of 5 is equal to 2x ln of 6, right? So what I'm doing is I'm saying this, right?
Right.
What would be the next thing you would do?
You want me to say?
Sure.
All right, you can subtract the x ln 5 to the right.
Right. You want to get all the x's on the same side. So this would be ln of 5 equals 2x ln of 6 minus x ln of 5, right?
Mm-hmm.
And then what's the next thing you would do?
Factor.
Factor. So I have ln of 5 equals x times 2 ln of 6 minus ln of 5, right?
Yep, and then you just...
And then I divide both sides by 2 ln of 6 minus ln of 5. And that cancels. And now I have x equals. And notice, these are just all values. If I put it into my calculator, I will have a number. But in ALEKS, they don't want to calculate. They don't want to give you a calculator. They just want you to give them that answer. This would be the final answer. This is the exact answer. Okay?
Yep.
Any questions?
No.
Good. So that ends today's session of logs, I believe. Yeah, we're not going to do that, and we're not going to do that. So, boom, we're done.
So wait, where do we find the LA worksheet?
Yeah.
I haven't put it up yet, but I'll put it up as soon as this is over. I'm going to stop sharing this thing so I can talk to you again. Let's see. Stop sharing. Okay, so now I can see you guys again.
So we have LA pre-worksheet and homework.
Yeah, so there's not gonna be, so you're gonna upload the pre-worksheet. I'm gonna upload an LA worksheet and the homework. Those will be due on Friday, and then on Friday we're just gonna do we're just gonna get a worksheet, and y'all are gonna work on it. If you have questions, I'll have me and 4 LAs with us, and we'll just go through the stuff, okay?
All right. Do we have a test Monday?
Yes.
All right. So what's the deal with that?
Well.
What are we gonna do?
So listen, I put up online on ALEKS. I put up a practice. It's not a practice. It's a test quiz. And that sounds weird. So it doesn't count for anything. It doesn't count towards your grade at all. I will delete it. I just want you to test your computer to make sure that you can download the lockdown browser and use the webcam, and everything works fine for the test on Monday. Okay? If it doesn't, please let me know. I don't know what to do about it at this point. What I'd like for you to do is see if you can borrow another iPad, something that you can take the test on that has a working webcam that the computer will download that lockdown browser into. So I really need for you to do, like I'm doing everything I know how. I really need for you to put a little effort into this. Maybe you have a brother or a sister or a parent who has another laptop that you can borrow for the test. That's all I'm asking. So please try not to throw it on me because I don't really know what to do. But if you can't figure it out, let me know. Does that make sense?
So you want us to get like a camera showing our paper?
Yes.
I see.
I want to be able to see your face that is you taking the test. I would, in all best of all possible worlds, I'd like to see your paper. So I know that you don't have a calculator. Like I want to see your hands. I don't want you to see your phones, your calculators. You know, I'm trying to figure out how to proctor it without actually being in the room with you guys.
So should we have like the camera filming like the side of like the desk showing us?
That would be great.
And like our
just like, you know, just when you take it, just show a picture of you and then like maybe pan it down to the desk so I can watch your hands. That would be my happiest thing. That way I know everything's good.
My computer's camera is like right in my. It's like at the top of my. Yeah.
I understand. So maybe you can put it back a little bit so I can have a bigger view than just of your face.
Okay.
Just play with it. That's why I put that quiz up online to mess around with. You don't even you don't have to worry about doing the problems. I just pulled problems from somewhere. I don't care about the problems. It's not for credit. It doesn't count. It's just to test your computer with the webcam and see if you can make, like, please try to make it work for at least, just try your hardest to allow me to proctor you.
Okay.
Okay, I'd really appreciate it.
I tried it, but the thing is that You can't see yourself when you're taking the test.
You can't see yourself. Oh, I don't know. I've never used it. That's what. So it basically is just taking it. It's just taking pictures of you, but you can't see what it's taking pictures of.
Yeah.
I gotcha. So all I'm going to ask then is if you could just push it back a little bit, your computer back away from you a little bit, so I have a little wider view than just your face. I'd appreciate it.
Okay.
Just do your best to give me the best shot I can have. And I understand. Like my webcam is attached to the top of my laptop, and it's going to point out at me. So I'm thinking if I push it down a little bit, maybe I can still see the screen, but I can also have it look down. You know what I'm saying?
Yeah.
Just do your best for me. I'd appreciate it. Whatever you can do to help me out, I'd really appreciate it.
You the man, Greenberg.
You guys are the best. I really appreciate you going with all this and not complaining. That wasn't too bad. It was kind of like a regular in-person lecture, right?
Yeah.
Yeah.
Okay. Good. So that's what we're going to do going forward. Huh?
It's just that I'm in a comfier setting. Well,
I know, right? And you get to eat and drink and do whatever. So it's even better. So no complaints, right?
No.
If you have complaints, just let me know. I'll try to fix them. I will. I really will try. Okay. Well, have a great day. I'll see you on Friday, and I'll upload the LA worksheet and the homework right as soon as we get offline.
Thank you, Greenberg.
all right.
Thank you. Bye.
Thank you.
Stefano, before you leave? Late?
I think he left.
Okay, I see that. It's okay.
Thank you.
Thank you.
Adios.
Bye, guys. Oh, hey, Dad, I didn't see you there. Now I see you.
I'm about to go do the office hours as well.
Okay, good luck.
Yes, ma'am.
I have a question though.
Yeah.
Where do I download the lockdown browser?
Say again?
Where do I find the lockdown browser?
You just go into the quiz and it'll have you download it right then.
Oh, where's the quiz?
So go into Alex and there's a quiz that just says something like, I don't know. I don't remember what it says, but it says not for credit. There's no password. You can take it over and over again. I didn't put a limit. I think it's unlimited amount of tries. So just go in there and just play with it. When you first go in, it should ask you to download lockdown browser.
Okay.
If it doesn't, let me know. I mean, I'm only seeing, like, thinking this is what I think should happen. So if it doesn't, let me know.
The thing is, I just can't find the quiz.
I can't hear you.
I can't find the quiz.
Oh, really?
Yeah.
Did you go to Alex?
Yeah, I'm on Alex right now.
Okay, hold on. Let me see if I can get to Alex.
Bye, Miss Greenberg.
Bye. See you Friday.
All right. See you Friday.
Have a good one.
All right, you too.
Gianfranco, you're in 002, right?
Yes.
It says trial not for credit, and it should be open. Do you see where on the quiz says trial not for credit?
No.
Where are you looking? Go to assignments.
Yes, I'm on assignments, and I cannot find them.
Is anybody else here?
Yeah, I think it should be under home and under the part where it says continue with your work. There,
To get home?
yeah, there should be like a small tab showing like a quiz.
Wait, hold on. Can I share my screen? Is that possible?
Yeah, hold on. I'm going to have to do something to let you. So, hold on. Let me give you permission. Okay, you should be able to share your screen now.
All right, so I'm on home.
Oh, no,
Yeah,
you put Alex.
Oh, Alex.
Open Alex, yeah.
This is good. Go through the whole thing so I can see it. Because I can't see it.
Okay.
Yeah, and so right there it says
See right down at the bottom there?
right here.
Click there, yeah.
Yeah, there you go.
And then download Lockdown Browser. And then you can also check your Lockdown Browser settings. Now, once you try to open it, you probably won't be able to open it without closing WebEx, because Lockdown Browser only allows you to have one screen open.
Okay.
So I think after this part, it'll probably kick you out of here. But this is where it is. So if you go up to the top, it should say, like go up, way up to the top of your screen, something should drop down all the way up.
Yeah.
Now, if you see where, does it say stop sharing somewhere?
Yep.
Yeah, just hit stop sharing. There you go. And I will stop. Well, I don't know how to stop making it presenter, but that's okay. Come on. Oh, I think I can.
Okay, well, see you everyone. Goodbye.
Okay, have a good one, guys.
Bye.
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 Does anybody else have any other questions?